Hello, Algebra Scholars. This is section 7.4. It's all about word problems, but the good news is there's only two kinds of word problems, and they both use charts to organize the information. The first type of problem we're going to do is called a total value problem. It says as part of a fundraiser, the Cobble Hill Daycare collected 430 returnable bottles and cans, some worth 5 cents each and the rest worth 10 cents each. If the total value of the cans and bottles was $26.20, how many 5-cent bottles or cans and how many 10-cent bottles or cans were collected? So we're going to draw ourselves a 3x3 grid. And in the first row, we will have 5-cent cans. No, scratch that. In the first column, we will have 5-cent cans. And in the second column, we will have 10-cent cans. And then in the third column will just be the total number of cans. Now, we do know the total number of cans and bottles, I guess, was 430, but we don't know how many 5-cent cans and 10-cent cans there were. So this first column, or excuse me, row, is going to represent the number of cans. And since we don't know these will be our variables. X will represent the number of 5-cent cans, and Y will represent the number of 10-cent cans. And that first row is actually our first equation, because we know the number of 5-cent cans plus the number of 10-cent cans must be equal to 430. Okay? And then I guess we would call this maybe the price. Each 5-cent can is worth 5 cents. Each 10-cent can is worth 10 cents. And what does that make the, we'll call this the total value of the 5-cent cans. So if we have X cans, and each one is worth 5 cents, the total value of the 5-cent cans is 0.05x. The total value of the 10-cent cans is 0.1y. And we happen to know that the total value of all of the cans and bottles was $26.20. We can actually leave this box empty. Nothing needs to go in there. And the last row will actually give us our second equation. So it's 0.05x plus 0.1y equals $26.20. Because the total value of the 5-cent cans plus the total value of the 10-cent cans actually gives us our total value. Now, to solve this system, it's a little bit tricky because we have the decimals. So let's leave the top equation alone. And let's clear out the decimals in the bottom equation. So let's multiply by 100. So what we get is 5x plus 10y equals 2,620. Now we'll use the we'll use the method of elimination, but instead of multiplying here, I'm actually going to, no, I take that back, I won't. Let's multiply the top equation by -5, and let's go over to the left here to do that. So -5x minus 5y equals negative, what, 2,150? Does that seem right to you? I think it's right. Bottom equation we'll leave alone. 5x plus 10y equals 2,620. And if we add, we see the x's have been eliminated. We get 5y equals, let's grab the calculator, 2620 minus 2150, 470. And we divide by 5, and we come up with 94. And remember, y is the number of 10-cent cans. So there must be 94 10-cent cans And to find the number of 5-cent cans, we can just subtract from 430, and we see there are 336, 5 cents, and 94, 10 cents. And we could check our work pretty easily by just multiplying here. The total value of the, let's do it in blue, the total value of the 10-cent cans would be $9.40, and the total value of the 5-cent cans would be $16.80. And if we add those together, we get $26.20, which is what it's supposed to be. So there's our answer. Okay, Algebra Scholars. So here is an example of a mixture problem. Gloria is mixing cranberry juice cocktail with sparkling water, and she was going to make a punch. So we're going to organize ourselves in the form of a chart, like we did for the last problem. And we are going to mix cranberry juice with sparkling water to make a nice punch. Over here is going to be the amount. Now we know she's going to make a total of 16 liters. We just don't know how much of each she's going to use. Once again, those are our question marks. We don't know. So because those are the unknowns, we'll give them variable names. X will be the number of liters of cranberry juice. Y will be the number of liters of sparkling water. And then the cost. Cranberry juice is $1.89 a liter. Sparkling water is $2.09 a liter. And we actually know that the cost of the punch is supposed to be $1.94 per liter. So unlike the last word problem, this box we actually can fill something in. And then this isn't really so much a value as the last problem, total value, but it sort of is. So we'll call this 1.89x. It's x liters at $1.89 per liter. I guess it really is a value. The total value of the cranberry juice is 1.89x. The value of the sparkling water is 2.09y. And then the total value of the punch is 16 times 1.94, which is $31.04. So our first equation comes from the first row, and our second equation comes from the third row. X plus y is 16. 1.89x plus 2.09y equals 31.04. I think we will do what we did, well, why don't we do this? Since we do have access to a calculator, let's multiply the top equation by negative 1.89. That will make the coefficients of the x's be opposites. So negative 1.89x minus 1.89y equals negative 30.24. Bottom equation, we'll just leave it alone. We're going to eliminate the x's, and it looks like we have 0.2y equals 0.8, if I did my math correctly there. So y would be 4. So 4 liters of sparkling water, which would then mean we must have 12 liters of cranberry juice. So you need a chart to do mixture problems and to do total value problems. That's it.